The stunning Kimi to robot exhibit was recently on display at Japan's Miraikan Museum of Science and Technology. About 130 robots from all over the world came together for this exhibition, which explored issues of human-machine interaction and the future of these technologies, while displaying the most recent developments in robotics. The integration of the Zero-type human-machine version 1.0 is a notable illustration of how physical reality is expanding. It is being created in cooperation with GR West and Nippon Signal to carry out maintenance and inspections on railroad bridges and overpasses. The highlight of this exhibition is the diverse array of robots gathered in one place. The robots range from foundational developments in robotics in Japan to the latest robots being shown for the first time in Japan, including the world's first humanoid robot Wibot-1, the heavy-duty general-purposed humanoid Rishiki Jinkai version 1.2, which stands over 4 meters tall, the remotely controlled avatar robot Ori Lab that allows you to participate in social events from anywhere in the world, and digital clones of real people created based on photographs, voices, and other data. In the second half of the exhibition, an interactive display will allow visitors to reflect on how humans will change alongside robots and what the future holds for us. It has been over 100 years since the word robot was coined. Robotic technology continues to evolve and expand, becoming indispensable to us humans. The definition, concept, and form of robots are also changing in various ways. This may mean that the relationships between robots and humans have become more complex. It can also be an opportunity to reflect on the way we humans exist. 2 legendary Japanese robots were showcased at the Japanese Museum, creations of Professor Hiroshi Ishiguro from Osaka University, who gained widespread recognition in the world of robotics for his lifelike android robots, from the Geminoid, Kodomoroid, Otonoroid series, and others. Each of Professor Ishiguro's creations becomes increasingly realistic and gains additional capabilities, enhancing their resemblance to living humans. At the museum, the Otonoroid was presented, which was modeled after real female bodies. The robot is made of special silicone and artificial muscles. Externally, the robot is almost indistinguishable from humans, and it can also talk and move. Museum visitors can try controlling the android, talk to them, and observe how their facial expressions and gestures change. The second robot by Professor Hiroshi Ishiguro showcased in the museum is the android Ibuki, with the face of a 10-year-old boy that realistically mimics human facial expressions. There are not many engineers and organizations working on creating realistic-looking androids and gynoids. This is partly because it is technically challenging to accurately reproduce human facial expressions on a robot's face, making such robots complex and expensive devices that have yet to find commercial applications. Ibuki is a humanoid robot with the face of a 10-year-old boy, equipped with a pair of arms and a wheeled platform on asymmetric wheels, which cause the robot to sway slightly while moving, imitating the human body's motion when walking. Ibuki's facial expressions include not only the display of emotions, but also involuntary movements that add to its realism. The robot blinks and slightly moves its head and eyes. The museum also showcased Orihime D-waiter robots from the Tokyo-based technology company Ori Lab. These robots serve as waiters in the newly opened Cafe Don Verbata. However, the most remarkable feature of this cafe is that the robots are operated from home by people with spinal cord injuries. A staff of 10 robot waiters, each standing just 1.2 meters tall, successfully works full shifts. All robot operations are controlled remotely using a computer. A special system responds to the slightest movements of the operator's eyes. The robot waiters can pick up objects, move around the cafe, and even interact with customers. The most socially significant aspect of the project is that bedridden operators have the opportunity to earn a living. The German company IBG Automation has developed an innovative robot with 2 arms and fingers. This robot is designed to perform complex tasks that require high precision and adaptability, making it ideal for various industrial applications. One of the key features of IBG's robotic solutions is their customization and flexibility. The robots can be adapted to perform specific tasks, such as handling delicate components in the electronics industry or assembling parts in automotive manufacturing. They are equipped with advanced sensors and control systems, allowing them to carry out precise operations autonomously. IBG's dual-arm robot is particularly notable for its ability to lift significant weights and perform intricate manipulations, Each arm is designed to mimic the movements of a human arm, providing a high degree of freedom and dexterity. This makes the robot perfect for tasks that require simultaneous handling of multiple objects or complex assembly operations. The Japanese company Honda, known for its advanced developments in robotic technologies, has introduced a new generation of telepresence robots called the Honda Avatar. This robot represents a significant leap forward in remote interaction, allowing users to perform tasks remotely with a high degree of precision and realism. The Honda Avatar robot is equipped with multifunctional arms with multiple fingers, capable of performing delicate manipulations and applying various levels of grip force. This enables the robot to handle a wide range of tasks, from opening bottle caps to lifting heavy objects. The robot can lift up to 15 kilograms, making it useful in various industrial and medical applications. The Honda Avatar robot stands about 150 centimeters tall and weighs around 85 kilograms. It is equipped with advanced control systems and artificial intelligence, allowing users to operate the robot with high accuracy. This robot is designed for use in various fields, including medicine, industry, and even space exploration. Let's move on to other robotics news. American engineer Suk-Shin Chum has introduced an innovative telepresence and motion translation system with visual feedback. This system allows the operator to perceive the robot's environment stereoscopically, as if the operator were physically inside the robot himself. It mirrors the operator's hand and finger movements on the robot, creating a fully immersive experience and the sensation of transferring consciousness into a robotic body. The television system was tested on 4 long-term and precise tasks: can sorting, can insertion, folding, and unloading. These tasks were performed by 2 different humanoid robots and successfully deployed in the real world. One of the key features of the system is its ability to perform tasks autonomously with high precision and success. This system is open for use by developers, allowing for the expansion of its functionality and application in various fields, requiring precise and interactive robot control. Write in the comments which of the robots shown in this video did you like the most. And there you have it. Japan's first humanoid robot museum is not just a technological marvel. But what does this mean for the future? Are we on the brink of a new era where robots and humans coexist in ways we never thought possible? The possibilities are endless, and this museum is just the beginning. We want to hear your thoughts. Do you think this museum is a glimpse into our future, or is it just a fascinating attraction? Share your opinions in the comments below. If you enjoyed this exploration into the world of humanoid robots, be sure to hit that like button, subscribe to our channel, and ring the bell to stay updated on all things tech and innovation. Thanks for joining us on this incredible journey. We've got even more exciting content coming your way, so stay tuned, and we'll see you in the next video.